Welcome back, everyone, and welcome to the Java Night. You've made an excellent choice because we have two great talks in store for you. First off, we have Gillis de Nijs. He's a senior software engineer at Capgemini and a great colleague of mine. And Gillis will be talking about data exploration with KSQL. So, Gillis, what is KSQL?
KSQL is a query language that you can use to query data that flows through your Kafka topics.
Cool. So, Gillis will talk more about that for us. If you have any questions, do ask them to the Q&A. So at the end, we can ask those questions to Gillis, and he can impart even more knowledge on us. Gillis, take it away.
Thanks. Hi, good evening. Tonight we're going to talk about data exploration with KSQL. I'll start with a quick introduction and show a quick overview of what Kafka is and what it looks like, and then I'll, of course, do a demo. My name is Gillis de Nijs. I'm senior software engineer at Capgemini for the past 3.5 years, and it's interesting to note that I have no prior experience with Kafka, and I'll show you why that doesn't matter. Kafka is an open source distributed event streaming platform. It's open source, so it's available for everyone to use. You can look into the code, you can add to the code if you want to. It's distributed, it's highly distributed even, so you can run it on one machine, on 1 million machines. It's the technology that LinkedIn created to basically send out the trillions of events they have each day, like messages and job feeds and everything they do. And it's event streaming, which means that you put in events and you can then later on do something with these events. Kafka in the basis is topic based. So you have a topic. I'm going to show you some topics later on. You have a topic and then you can add events to that topic. So you have one or more producers that add events to a topic, and those events go at the end of the stream. It's a time series database, so it's time-based events, and they happen in a certain order. And on the other hand, you have consumers that take events from these from the topic queue, so to say, and then use them to make a notification in your system to change something on disk to whatever. A single topic with a single partition is not so interesting. So Kafka allows you to split a topic over a lot of partitions. And in this example, I have 2 partitions. It's the same topic, so it's the one thing that you write to, and this topic can then be used by different consumers. This is basically how Kafka does distributability. So you can have a lot of partitions, you can have thousands of partitions if you want to, and then consume these from several different consumers at the same time. Kafka will make sure that the partitions themselves are synchronized, so if one of your partitions fails, then it's not that bad because the data is replicated if you choose to. So how to run Kafka? Well, that was breeze actually, because you just use Docker. I used the Confluence platform trial. Confluent is an organization that adopted Kafka and made their business around it. Ben will talk about Confluent later. But the Confluent platform trial is really simple. It's just a Docker Compose file that you can run on your machine, and then you'll have a fully configured Kafka system. So what we're going to do today is obviously use Kafka, because that's what we're here for. I'm going to put events in it from Twitter, because Twitter streams millions and millions of events every second. I mean, it's a whole lot of data, and I think it makes for a nice use case for us. Then Kafka is connected to a KSQL DB server that allows you to basically talk to these topics through KSQL. And then we'll be using KSQL to actually query those topics and create some streams. So first we need to connect to Twitter. I just use a standard developer account from Twitter. And I put in my tokens, my secrets, my keys, etc. And from there on out, I created Twitter clients with the credentials that I have, and I create some properties that allow me to connect to Kafka later on. Then on this end, I use a sampled stream, which allows me to stream 1% of all the tweets that are coming in through Twitter right now. And on these tweets, I check if they're sensitive, because we don't want too sensitive tweets here. It's a live demo after all. And if they pass that test, then I'll accept them in the tweet consumer and in the user consumer. And they themselves produce tweets and users to Kafka topics. This Kafka topic is Twitter tweet, and this Kafka topic is Twitter user. So I've already started my my Docker Compose file. I have 4 brokers, a control center, a KSQL DB server, and a zookeeper that makes sure that the brokers know which one is the leader, which one are followers, how they replicate to each other, etc. So this is the control center that is part of Confluence platform. It has a default name of controlcenter.cluster. I did not configure anything. I just started 4 brokers and a zookeeper, the control center, and the KSQL server, and that's it. So I have 4 brokers. I have a lot of partitions. I have some topics. Most of these topics are default topics. Kafka uses the topics themselves to actually make sure that that it can do monitoring, that it can make sure that everything is up to date, that the partitions are in sync with each other, etc. And I have one KSQL DB cluster configured that is a single instance. So here I have 2 topics. I created these beforehand. I gave them both 10 partitions. And I'll run my Java class to see if we can actually send data from Twitter to this to these topics. I'm going to run this. Packages not exist. Great stuff. All that. Demo gods have mercy. I ran this like 3 minutes ago, but it seems I broke something. Maven clean package. There we go. Should be good. Here we go. I got a lot of debugging information from the Kafka stuff. Show you how you can connect, etc., etc. And as you can see here, live, we're getting tweets streaming in. So these are live tweets. You can see they're scrolling by pretty quickly. And we should be able to see these in the control center. So I'm going to start with Twitter tweet. If I look at messages, and here you can see the messages are coming in live. I did not do any filtering other than taking out the sensitive tweets, so this can be anything basically, and it's just rolling in as we speak. I told you before, it's a time series database, so everything has a timestamp, so Twitter knows in what order Kafka knows in what order the events came in and how important they are. If you look at a single tweet, then you can see what it is. It's apparently some Black Friday thing. It was tweeted by Twitter for iPhone, etc., etc. So here's all the information that you would expect from a tweet, except for the user, because the user is only linked as an author ID right here. But luckily, we put the users in a different topic, so I'll move back to topics. You can see that we're actually producing bytes per second, so right now we're putting data in the cluster. I'll stop this because I think we have more than enough data now. And if I look at my my data, then here I can see the different users that we have. Location, a description, a username, a profile image, etc. All the stuff that you would expect. Okay, now let's take a look at KSQL, because we have a lot of data, but we want to look at it. I prepared some queries beforehand, because doing things live is basically tempting the demo gods. So we'll start by creating a stream. And a stream is in fact a sort of filtered placeholder for one of your topics. So if I run this query, then you can see here that the stream has been created. It should appear on the right as well. Yeah, there it is. So here, ST for stream, tweet language. And this stream is basically the same as the topic that we have, the Twitter tweet topic, except that this has been filtered for ID and language. I did not need to specify anything. I just say it's from the Twitter tweet topic. It's in JSON format, and I use ID and lang because they are present in my JSON in my topic. So once I've done this, I should be able to select this from tweet language, emit changes. Here you can, I'll start with earliest because I stopped recording new tweets. There are no tweets available, but if you start with earliest, it will go back to the start of your Kafka topic and actually send them out in order. So you can see this performs the same as a topic. It allows you to, in this case, sort of real time, look at the events as they came in. So here we see tweet IDs and then languages like Korean and Portuguese, English, a lot of English, Finnish, more Portuguese, Thai, Indian, etc., etc. Well, one of the things you can do is create a table of that basically materializes the data that we have in the stream, and that allows you to look at totals, for example. So you can do an aggregate languages. Emit changes. Here you can see that the table records the data from the stream that we just created, grouped by language. So this is counted by language. And you can see the same language coming by often because it starts at the beginning and then runs over all the languages, and every time it counts a new language, the count is increased. So this table that we have here basically contains the number of times a language was used in a tweet at that time, because this is a time series database. If you want to look at just the total for a certain language, like for English, for example, you can do that as well by just selecting that language, and then you'll only get the last occurrence of that value in this table. So if I do this, then I can see that my topic contains about 4,000 tweets in English. Well, going from there, we should be able to create a stream of tweet that contains nothing more than the string, the author ID, and the text, or the ID, the author ID, and the text, which is basically a view of the full topic, except that we took out everything that we don't need right now. So if I run this query, I'll have a stream created that's called tweet. It contains an ID, an author ID, and the text, which is the data of those tweets. I'll create another stream that does the same for user, where I just select the ID and the username. Run query. Here's my user table, just the ID and the username. Again, I can select from these if I want to. So I can select start from tweet, emit changes. takes a while. I wonder why. Oh, there we go. So here you can see, this is just the ID of the tweet, the ID of the author, so which is the ID from the user table, and then the text. She is so pretty. I love Ruby. Well, isn't that wonderful? And we can do the same for the user table. And here you can see the same happen. It's just the IDs of the users with their usernames. So I should be able to join these together, and I can. I can create data. I can create a stream, in this case, that links the two together. And here you'll see an interesting thing, because Kafka supports windowing and KSQL supports windowing. So in this case, I can say I want to create a stream tweet author, which selects the tweet ID as tweet ID, the text, the author ID, and the username from tweet. It joins the user within 10 minutes on tweet.author_id is user.id. And this within 10 minutes is how Kafka takes events from the different topics and tries to find a window in which they belong together. If I make this window very, very small, then in my case this should still work, because I recorded my tweet and my user pretty much at the same time. But you can use windowing, for example, to select orders that came in and have not been paid within 10 minutes, for example. If you have different data, then you can use this windowing to pull those together. So I have this stream now. And from this stream, select star from tweet author, image changes. Oh, not sure what happened here. Refresh this page. There we go. So here you can see that now I created a stream that contains the text, a bit more text, the username, the tweet ID, and the author ID. So summarizing, it was really easy to get started with Kafka. You can just basically start up some containers and have a go with it. Putting data in is easy. Getting data out is easy as well. You can use KSQL to look at the data that you have before or while it's being consumed. And yeah, I think it's a lovely tool. It really is wonderful. I put some links in the slides. I'll share the slides later on. I'll put everything up on GitHub as well, so you can just run it yourself. The only thing you have to do is basically install Docker and Docker Compose and get some development keys from Twitter, and then you should be good to go. That's all I had to say. I'm wondering if there are any questions.
So, Gillis, thank you very much. Great talk, great introduction, showing how easy it is, even with no prior knowledge.
No prior knowledge.
Kafka. So you have a few questions from the audience, and I have some myself as well. Soam asks, why did you need to add image changes to some of the queries?
Right. So the queries themselves, especially when you create tables or streams based on topics, the topics are in a way live. So you look at a topic while it's happening. And KSQL does that as well. So if you select data from a topic, then the image changes will make sure that everything that happens to the topic while you're selecting will appear in the output. It's the same as with the table. I created a table, and image changes make sure that the table is live. It actually contains the current data from the topic. If you want to select a single thing, then you can add where, then you can get rid of the emit changes, like I showed with English, for example, and then you use give me everything with language English, and then you'll get the latest state from that table. So emit changes allows you to basically view the data as it's happening in the format you specified by creating your own streams or tables. I hope
Great,
that,
thank you. I think
that
it
answers
very much the question. Another question we have from one of our viewers. So Twitter generates a huge data stream. How do you distribute the loads over the threads?
I didn't. I let Kafka do that. I don't do anything. I just started 4 brokers in my case. As you can see here, it's just I started some brokers, and I do nothing more than basically create the topics, and then Kafka does the rest. And I'm assuming that if you look into this and you want to scale out or whatever, then you can just keep adding brokers and change your number of partitions, etc. I'm not that that good with Kafka yet that I would know exactly how to configure this, but I know you can configure it fairly easily. If you look at the brokers, for example, here, then you can see all the brokers that you have, how they perform, what their throughput is, etc., etc. And here there's some configuration options that give you all the metrics and things that you need. Especially if you use Confluence Platform, then you can do things like Health Plus that allow you to monitor the full platform, including your brokers, your Zookeeper, your KSQL clusters, etc., etc. And then you can just see how everything is doing and where you can improve. So right now I didn't configure anything. I just created 2 topics and I gave them 10 partitions, and that's pretty much it.
Great stuff, excellent. So a question I have myself, and please do say if it's too far-fetched, but would it be possible to try and get some of the BuildConf 2021 tweets? Or is that something that would be too far-fetched for a small demo position we are in now?
In theory, it should be possible, yeah.
Can you show us how it would be done, even if there's no results?
Sure. If you look at, you have to know obviously what data you're looking at. So if you look at the Twitter tweet and we look at the messages, then if I start at offset 0, which is the very, very start of everything, everything is offset based. Every consumer knows where it is in the current topic, so it has a certain offset that it talks to, and then when it reads a message, that offset is increased by 1. So here you can see the offsets for the different tweets that I have in partition 0. I try to open one of these. I know that in this case, the tweet contains entities, and these entities contain hashtags, and in this case, we don't have any hashtags. So I'd have to look for something that contains hashtags. But yeah, you can totally do create a stream over hashtags, like create stream hashtags with the ID, which is the ID from the tweet, and the text from the tweet, then the entities hashtags, which I'm not sure what this is. This might be a string, I'm not sure. With Kafka topic is Twitter tweet, because that's the topic that we use. The value format is JSON. Entities. This is supposed to work. I do know that you can select data from subparts of streams, but maybe that only works on tables. I haven't actually tried that out yet, but I think we should be able to select star from what do I now call hashtags, where hashtags. Let's try this out first. Mm-hmm. Well, here the hashtags are obviously still JSON, so I need to do some extra magic to make sure that
But
we
you can easily then filter on those
yeah, sure, you can
hashtags.
filter on those hashtags and get them out as well. Yeah.
Awesome. So another question maybe from the audience. You're setting up Kafka in KSQL. You already mentioned it was very easy to set up. Were there any issues or problems whatsoever you ran into?
Nope. I just used Confluent has a CP all-in-one, which is the Confluent platform all-in-one Docker compose file. And I took that and I removed the stuff that I didn't need and I added some extra brokers. And that's it. It was really easy.
Easy peasy, lemon squeezy.
It took me maybe 10 minutes.
Very nice.
Yeah.
And another question from the audience. You use Kafka together with KafkaDB. Is it also possible to use Kafka with another database?
Yes, you can on both ends because Kafka allows for something called connect. And connect allows you to get data from a different source. Like if you have a database and every change in that database you send out to Kafka, then you can use that as source for your data. But the other way around works as well. You can use connect to watch a topic, for example, for certain things and push that out to a database. I know, for example, a colleague of mine uses Kafka in combination with MongoDB, where they take basically the updates from the Kafka topics and then push those out to MongoDB. So if they select data from the MongoDB, they will always have the latest view of the current status. And in Kafka, they will have the full history.
Cool.
Yeah.
All right.
Really is cool.
Very nice. Maybe another question from myself. Interested. Is there now a sort of a personal hobby project that you would use Kafka in?
Well, it's great for things that change, like dashboarding. Maybe if you start automating your home, for example, and you want to see how your solar panels did over time, for example, then you would be able to get the data from the solar panel currently, and then just put those in events, and then based on those events, maybe add them up per day or whatever. Sure, you could do stuff like that.
And in the end, create a better environment and a better world.
Obviously, yeah.
Kafka saving the world.
Kafka saving the world,
Excellent.
yeah.
Well, on that note, I think we've run through all the questions we have. We're going to have a short break. After the break, there's going to be a network carousel where you can all talk to other participants of the evening, have small chats with each other and get to know each other, form a real community. After the network carousel, we'll continue with the second part of the evening, where here in the Java evening, Ben Stopford will be giving a talk. Ben is from Confluent, the company, like Gillis said, that sponsors Kafka. So I hope you all enjoy very much having good conversations in the network carousel, and we'll see you after that. Thank you.